This is Mr. Beck Does Your Homework. This is AP Physics, Homework 2.7, Projectile Motion. This is question 1 and 2. It says, a baseball is thrown at an angle of 28 degrees relative to the ground at a speed of 25.3 meters per second. So I'm just going to stop right there. I've got the ground. I've got a baseball being thrown at some angle at 25.3 meters per second and an angle of 28 degrees. The ball is caught 54.0936 meters from the thrower. So I know that it's going to move over here 54.0936 meters in this direction. So that is going to be a displacement here, and that's when it takes its path up and back down again. The acceleration due to gravity is 9.81 meters per second squared. How long is it in the air? Answer in units of seconds. So now I've got to start my x world, y world. So let me see what I know in my x world, and let me see what I know in my y world, because I have to separate these. I know that in my y world, my acceleration is gravity is negative 9.81 meters per second squared in this problem. I can't put this velocity in with this angle because that's what I call the monster. I have to split that into an x and y component. What I do know is at the end of the throw, 54.0936 meters is my displacement. So x is 54.0936 meters. I also know that my acceleration in the x world is 0 meters per second squared. Now the one other thing I know, this is where tricks come in handy. I know that if it goes up and comes back down, my displacement in the y world is going to be 0. That's going to help me out later on. Now I can take this monster and split it into its x and its y components. So it's going to have a velocity in the x direction, and it's going to have a velocity in the y direction. For the x direction, this is going to be the velocity once and forever. For the y velocity, this is going to be the initial velocity in the y world. So my initial velocity in the y world is going to be my Vy, which is going to be this velocity. Since y is opposite that angle, opposite has to do with the sine, SOHCAHTOA. Sine is opposite over the hypotenuse. So that is going to be my velocity times the sine of theta. So that's going to be 25.3 times the sine of 28 is going to be my initial velocity in the y world. My velocity in the x world is going to be my Vx here, and that's going to be the initial, the final, and all the velocities. And that's going to be my velocity, this velocity, times the cosine of theta, because this is adjacent to the angle with the hypotenuse. So that is going to be my 25.3 times the cosine of 28 degrees. So I've got an x velocity and I've got a y velocity. Now what I'm looking for, how long is it in the air? I'm looking for a time. Well, I have a initial velocity, I have a displacement, I have an acceleration, and a time. So I could try, my first instinct is that my displacement is my initial velocity times time plus 1/2 my acceleration times time squared. Now I might worry, wait a second, now I have an initial velocity, so I might have a quadratic here. But luckily, since it comes down to its starting point, it's going to wind up with a 0 over here. So let's just see what that does. 0 equals V0t plus 1/2 gt squared. If I subtract from both sides, say this one, let me just rearrange this. So I'm going to get V0t equals negative 1/2 gt squared. Notice there's a t and a t squared. This is going to be easier if I divide both sides by t. That way this goes away with one of those, and this goes away with that. And so now my initial velocity is going to be negative 1/2 gt. That makes it a lot easier. Because now I'll solve for my time. Well, that's going to be twice my initial velocity divided by g, and that's going to be a negative, and the g is also negative, and that's going to give me my time. So when I calculate twice this initial velocity, this 25.3 sine 28, is my initial velocity that goes in here. So twice my y velocity, negative, divided by negative 9.81, will give me a positive amount of time. So that's going to give me my answer for time. Now it says, how high is the tallest spot in the ball's path? Well, that's a different question. Here, y is not 0, because this was all the way up and back down. So I have a separate problem when I'm looking for this spot right up here, my highest y velocity here, my highest displacement there. Well, I've got two ways of going about that. The first is to set my final velocity to 0. I've got my initial velocity. A final velocity is 0 in the y direction, up and down here. So I can figure out, there was a much easier way to get to time. I can figure out my initial velocity in the y direction. I have that. I have my displacement. I have my acceleration. And I'm looking for this displacement. So let's see. For this problem, I know that my acceleration in the y world, my acceleration is negative 9.8 meters per second squared. My displacement is what I'm looking for. My initial velocity is going to be that 25.3 times the sine of 28. And my final velocity is going to be 0. So I could do v squared equals v0 squared plus 2gy and solve for y here. So my final velocity is going to be 0, so that one goes away. So now I got my final velocity squared is going to be 2gy. So y is going to be my final velocity, my initial velocity squared. This is initial velocity. I'm sorry, I'm crossing out the wrong one. So this is the one that goes away. So it's going to be negative. My velocity squared is 2gy. So y is going to be negative v squared over 2g. So that's going to be my y. That's going to be my height. Now, an easier way to get to this time would have been just to go in the x world. Since I had my x velocity is 25.3 cosine 28, and I know that my distance is 54.0936 meters, I know that my distance is my velocity times my time, or my time is going to be my distance divided by my velocity. So this would be a good way to check that I get the same time as I got there. This time should be the same.